physicsacademyonline.com, we teach physics in an interesting and engrossing way.
Rectilinear motion by calculus. Now, some time back we did a lecture whose topic was graphical analysis of rectilinear motion. And if you remember, we had there discussed a particle moving in a straight line and had learned to draw its position time graph and from there velocity time graph. Let me recall that with some figures. So as you can see here, we considered the motion of a particle moving along the x-axis. So I took, this was my origin, this was my taken to be the x direction plus x-axis, and here is a body and its position with respect to the origin is changing. As you can see, at initial time t1 its position was, coordinate was x1, the later time t2 the position became x2, and so on, all measured from the origin where x is equal to 0. At all intermediate points here onto this path, we can find out the position x of the particle as a function of time, and or we can have some data that gives me the values of x and t, and by plotting this data we could have a graph of x versus t. See, t is along the horizontal axis, x along the vertical axis, x is a function of time, and that is called the position time graph of the particle. We have done these things. We have done further that at any given instant during this motion, if I wanted to find velocity, I just need to take the time into consideration, draw a vertical line parallel to the x-axis, x that is vertical axis, and where it cuts that given graph, that was the green line here, draw a tangent to the graph at that point, and the slope of this tangent gives me the velocity vector. So if you recall the velocity, well, let me show just one example what I did here, just extending this tangent line here and measured the angle made by this tangent with the t-axis, letting me call this as theta. The slope of tangent is coming out to be m, that is tan theta. This represents graphically the velocity of the particle at that particular point, instant, and that is written in calculus language as dx dt, derivative of position with respect to time. This is the way you could find out velocity at every single instant of motion of the particle and could draw my VT diagram, velocity time diagram. We call it xt, that is position versus time, then VT, velocity versus time, and the logic is very simple. You get the value of v at every single instant by finding slope of the tangent, and that is the value of the v here. Make another table and plot the graph, that is VT diagram.
We strongly believe if students follow video lectures regularly and clear their doubt effectively through physicsacademyonline.com, they will attain enough expertise to perform confidently to reach their academic goals in board level examinations or any competitive examinations anywhere in the world.